Hey there, folks. Okay, continuing the notes on page 8, we go from ionic bonding to covalent bonding. When we have nonmetals bonded to nonmetals, it's covalent bonding. Covalent compounds are sometimes called molecular compounds. This also could be called molecular bonding, but more often you'll see the phrase a molecular compound. That's a synonym for a covalent compound. Okay, what's the difference between this and ionic bonding? You know, this is about sharing of electrons. When electrons are shared, the bonds are not quite as strong as when electrons are transferred and make the positive and negative. So these bonds are not as strong, and that means covalent compounds have low melting point and low boiling point. You don't have to add very much energy to get those particles and those molecules to move further apart, go from a solid to a liquid or a liquid to a gas. Covalent compounds can be liquids, they can be soft solids, or they can be gases, whereas ionic compounds were all brittle solids. Okay, now we need to draw Lewis dot diagrams so we can see how these electrons are shared among these non-metals. So here we go. We've got NH3. Anytime you have anytime you're trying to draw a Lewis dot diagram of something where you have one atom of one element and then several of another element, put the one in the middle and distribute the others around. It'll make things work out better. Okay, first thing we have to do is figure out the valence electrons that we have available to work with for our bonding. Hydrogen has one valence electron, so let's draw an X for that one, and an X for that hydrogen, and an X for that hydrogen. Nitrogen, look it up in your periodic table, it's got 5 valence electrons. So here we go, 1, 2, 3, 4, and 5. And now we have to figure out how to share these electrons to make each element happy. Now, hydrogen is so small that it only needs 2. It doesn't have to have a stable octet. Two electrons are enough for hydrogen. So this is where we draw the loops to show what electrons are being shared where. So the hydrogen is going to share that electron with the nitrogen. This hydrogen is going to share this electron with the nitrogen. This hydrogen will share this electron with the nitrogen, and now the hydrogens are happy. But now we have to count to see if the nitrogen is content and has a stable octet. Well, nitrogen has 1, 2 from this lone pair of electrons, 3, 4, 5, 6, 7, 8. Okay, nitrogen is happy, so we're ready to do our final version of this molecule, and we draw an H and an N and an H. Those are single bonds in between there. 2 electrons makes a single bond. We got one more hydrogen down here with a single bond, and then we just put those 2 lone pair electrons right there. It's a lot neater looking than this one. Okay, we've got O2 gas. Oxygen gas, well, that is a covalent compound because it's nothing but nonmetals. And so here's what we got to do. We have to take each oxygen and draw its valence electrons. So here we go. We got 1, 2, 3, 4, 5, and 6. And I've done this one before, so I know that I want my single electrons over here. It's going to make it a little easier to do my sharing. And with this oxygen, 1, 2, 3, 4, 5, and 6. All right, each oxygen has 6. Each oxygen needs 2 more, so each oxygen is going to have to share 2 electrons. So how about we share these 2, and now each oxygen feels like it has 7. But now we could also share these 2, and each oxygen now feels like it has 8 electrons. That's just a rough draft. Here's our final version of oxygen gas. Since they're sharing 2 pairs, that means it's a double bond. Each bond is 1 pair of electrons, but then those oxygens also still have their 2 lone pairs off either end, and I'm kind of drawing them a little bit diagonally there because I know a little more about chemistry than you guys do. But don't worry, just draw them. I would say draw them like that, and you will be good. Okay, final type of bonding. This is a new one. If it's not ionic and it's not covalent, it's going to be metallic bonding. Metallic bonding is when you've got a metal, nothing but a metal. Okay, and in fact, this isn't a metal isn't considered a compound because you've just got an element like iron or aluminum or sodium or potassium. Okay, now in this case, it's a little bit different and a little more loosey-goosey than our other types of bonding. We've basically got valence electrons floating around among the atoms of the metal. And so we say that metals bond by having a sea of mobile electrons. This phrase is used many, many, many times on Regents questions. We got a sea of mobile electrons floating around amongst the atoms. And so the nice thing about this is with all those electrons moving around, metals can conduct electricity when they're a solid because there are all these electrons moving around among the atoms. This is why metals also are malleable, because even if the atoms slide past one another, the electrons can still move all around to continue holding them together. So metals are malleable. If you hit a metal with a hammer, it will bend, it won't break or shatter. And this type of bonding is very strong. So metals have very high melting points and high boiling points. What's that phrase you need to know? A sea of mobile electrons. And so here we're going to do a little diagram. This is not a Lewis dot diagram, but this is just a diagram to help you visualize this sea of mobile electrons. This is going to be iron, Fe as a solid, and these are all the iron atoms. And the atoms basically have a positive charge from the nucleus, and then there are lots of electrons. The valence electrons are just going all around in between those positive metal atoms. And so we have something like this. We've got a sea of mobile electrons distributed and holding together these positive metal atoms. And that is metallic bonding. Oh, there's one more electron. Okay, and that is the end of the notes, and watching and listening.